Now we're ready for our third strategy for solving our systems equations, and this is one called using a strategy called elimination, or sometimes it's called linear combinations. Basically, the idea is we're going to combine the two equations together to get one of our variables to drop out, to turn to 0, so we can just solve for the other variable, and then we go through the normal steps of kind of plugging that back into the problem to find the second variable. So here's what that's going to look like. The idea is we want to find one of the variables that are kind of opposites of each other, so that if I were to add these two equations together, -3 plus +3 would turn to 0. I'd have +4 and -6y, so that'd give me -2y, and 12 plus 18 is, 12 plus 18 is 30. Notice now I'm down to just my y. Quick solve, and I get y is equal to -15. So by adding those two lines together, it causes one of my variables to add up to be 0, so it drops out of the equation, so I can focus on just the other variable. Now I follow the same steps I normally would. I'm going to plug that variable back into one of my original equations. Okay, and again, it doesn't matter which one. So maybe I'll use this one. I'm going to plug in y of -15 in for y. So I get -3x plus 4 times -15 is equal to 12. So -3x minus 60 is equal to 12. Add 60. And then I just go through my steps of solving it, and I get x is equal to -24. My y was -15, so my solution is -24 comma -15. Those are my solutions to my system of equations. So same on the next one. I'm going to add the two rows together because my -5y and my +5y turn to 0. So I get 5x is equal to 10. Quick little bit of solving, and I get x is equal to 2. I'm going to plug that x back into one of my equations. So 3 times 2 minus 5y equals 1. So 6 minus 5y equals 1. Now it's just a simple two-step equation for me to solve. Divide by -5, and I get y is equal to +1. So I get a solution of x is 2 and y is -1. So +1. So 2 comma 1. Now on my next one, you'll see that my 4x's both have the same size, the same coefficient, but I need them to have opposite signs. So one way to think about it is, instead of adding the two of them together, we really want to subtract them. But think of it when we were doing integers. Subtracting is really the same thing as adding the opposite of the number. So another way to think about it is, instead of subtracting, it's kind of like multiplying the whole line by -1. We're going to change everything into its opposite. So instead of 4x, I'm going to have -4x. Instead of -3y, I'm going to have +3y. And instead of 18, I'm going to have -18. So I basically took that entire line and multiplied it by -1. I found their opposites. Now I can go ahead and add them. 4x and -4x is 0. 2 plus 3 is 5y. 28 and -18 is 10. And I get a y of 2. So the whole idea behind elimination is we can very quickly get down to just one variable. It's a simple one-step equation to solve to find the value of that variable. Now we plug it back into one of our equations. Always go back to an original version and plug your y into that problem. And now we can solve for x. So I put in 2 in place of y. So 4x plus 4 equals 28. Solve my quick little equation here. And I get x is equal to 6. So I had a y of 2 and x of 6. So my solution is 6 comma 2. So that's our basic steps for elimination. All right, now I'm going to jump ahead in my note packet, and we're going to combine this with the second part of elimination, which is where we need to do a little bit of multiplying to go along with it. So you'll have to flip ahead in your notes to find these problems. But here's the basic idea. We still want to use elimination. We still want to get things to line up, but we don't have the right numbers to do that. okay? A 2x and a 3x are not going to add up to be 0. A 1y and a 2y are not going to add up to be 0. So the idea is either with one of the equations, or in some cases you'll see both of the equations, we're going to multiply that whole equation by something in order to help get one of those variables to match up. So I'm going to choose to multiply this whole line times -2. And when we do it, you're going to see what happens. So that -2 gets multiplied times everything. So I get -4x minus 2y and -46. But now you'll see that my 2y and my minus 2y are going to cancel each other out. They're going to turn to 0. So I have 3x minus 4x is -1x. 37 and -46 is -9. So I get an x of 9. Now I plug my x back into one of my equations. So let's use this one. Always go back to one of the original versions. So 3 times 9 plus 2y equals 37. So 27 plus 2y equals 37. Solve my two-step equation. And y is equal to 5. So I get a solution of 9, 5. All right, second one. So x plus 7y equals 12. 3x minus 5y is equal to 10. So there's lots of different possibilities. I can get my y's to match up. I can get my x's to match up. But I like to go with the one that's going to require the fewest steps. So in this case, if I were to multiply that whole top line by -3, that's going to give me a -3x minus 21y equals -36. But now that matches up with the positive 3x in the other equation. So my x's turn to 0. I get -26y is equal to -26. And I get y is equal to 1. I'm going to plug that 1 back in for y. So x plus 7 times 1 equals 12. X plus 7 is equal to 12. So x is equal to 5. So I get a solution of 5, 1. All right. So in these next two, there's no easy way to turn one of them to match in with the other one. So we're going to have to change both equations in this case. So it's entirely up to you on whether you change the x's to match up or the y's. I usually go with which one is going to require the fewest steps or which one already has the right signs. I just need to change the coefficients. So I'm going to focus on the y's because one's positive, one's negative. But I want to turn the 3 and the 5 both into the same thing. Well, a common multiple of both of them is 15. So I'm going to multiply the first row times 5. That's going to give me 20x plus 15y equals 40. I'm going to multiply the second row times 3. So 9x minus 15y equals -96. But you'll see that now my y's are going to match up and turn to 0. 15 and -15 is 0. So I get 29x is equal to, sorry, I'm just checking on my math, is equal to -56. Okay. Divide everything by 29. And x is equal to, oh, sorry, I had a mistake here. I knew it wasn't quite coming out right. My apologies. So 23 times 3 is -69, which gives me a -29 here. Divide by 29, and I get -1. Plug that back in. Again, go back to one of the original versions, don't use your modified versions when you're checking it. So put in x of -1 back into my equation. 4 times -1 plus 3y is equal to 8. -4 plus 3y equals 8. Add 4, and I get 3y is equal to 12. So y is equal to 4. So I get a solution of -1, 4. All right, last one. 3x plus 2y equals 10. 2x plus 5y equals 3. So in this case, neither the x's or the y's have opposite signs. So I'm going to have to change one of them to a negative. So it doesn't matter which one I tackle. So this time I'm going to tackle the x's. I'm going to multiply this row times 2. That gives me 6x plus 4y equals 20. I can also turn a 2 into a 6 by multiplying by 3, but I also want to switch its sign, so I'm going to multiply by negative 3. So I get negative 6x minus 15y equals negative 9. But now you can see my x's are ready to cancel out to turn to 0, and I get negative 11y is equal to 11, and y is equal to negative 1. So that time I had to do something to both equations to get it to work. But now I'm going to go back to my equation. 3x plus 2 times y is negative 1. Gives me 10. So 3x minus 2 equals 10. Add my 2. 3x equals 12. So x is equal to 4. So I get a y of negative 1, an x of 4. So that gives me a solution of 4, negative 1. All right, hope that helps, makes sense on how to use elimination, and then we'll practice it in class.